Hello and welcome to this Haas tip of the day. Now we all know what this guy is, but the rest of these are also taps, but they're all made for a different purpose. This guy here might be perfect for hand tapping, while this one is definitely not. Some are great for specific types of holes, and others are great for specific types of materials. And it's easy to spot the differences between all these taps if you know what to look for. So that's what we're going to do today. We're talking taps and snow plows. You'll want to see this. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, the important things that make one cut tap different from another all happen here near the tip, where the cutting face of the tap first cuts our threads. The angle of this cutting face right here, as it turns out, has a giant impact on what a tap can be used for. And to illustrate this, we need some snow and a snowplow. If our plow is set to a negative angle, which way do we expect the snow to be pushed? Hey, don't look at me like that. This is going to change the way we think about taps. Okay, of course, blade tilted left, the snow goes left, towards the bottom of your screen. Now if we rotate the blade, giving it a positive angle, we expect our snow to pile up on the other side, towards the top of your screen. And if we straighten up our blade, our snow is going to escape in any direction that it can, piling up both to the left and the right of our truck. We can tell which way that snow is going to be pushed based on the angle of our plow. And in the same way, we can tell which way chips are going to be pushed every time we tap based on the angle of our tap's cutting faces. Here I have 3 taps: a spiral point tap, a spiral flute tap, and a straight flute cutting tap. Yes, the flutes might be different between these taps, but I'd like for you to ignore that for now and focus only on the tip of the tap, on our cutting face where everything important happens. Now, just by picking up a tap, any tap, and looking at that cutting face, we should be able to tell which way the chips are going to go, up or down, just like we could tell which way the snow was going to go with our snowplow. A spiral point tap will force the chips downward into the hole. A spiral flute tap will pull the chips upwards out of the hole. And a straight flute tap will just shrug its shoulders and let the chips go up or down, whichever way they want to flow at that moment. Knowing which way those chips are going to go is really important. It's critical when choosing a tap or when programming a tap you've already chosen. Now, if I have a blind hole, which just means you can't see through it like we can with this one, you'll have to be really careful if using a spiral point tap. With a spiral point tap, the chips get forced in front of the tap. And if there's not enough room at the bottom of that hole, those squished chips are going to chip your tap or even break it. But not all chips are the same. Some of these materials leave long stringy chips when being machined. These long chipping materials, like some steels and aluminum, create this cut thread wire that has to go someplace, either out of the hole or deeper into it. Our spiral point or our spiral flute tap dictate which direction these chips are going to go based on their axial rake angles. That's the angle on that cutting face. Some materials, like cast iron, are short chipping, creating almost powdery chips. It's usually on these short chipping metals that we'd see a straight flute tap being used. Now, chip control is only half of our story. The other defining feature of our taps is the chamfer on the tip. These 3 taps show the difference between our 3 most common chamfer types: taper, plug, and bottoming. Now, here in the US, when we say plug tap, it's more than just a name. It's a technical term describing the chamfer on the cutting tip of our tap. 4 to 5 threads worth of chamfer is what makes a plug tap a plug tap. In the same way, A taper chamfer is usually 8 or 9 threads long, and a bottoming chamfer tap has a chamfer that is about 1 or 2 threads long. This is the vocabulary of taps, the grind on that cutting face, and the amount of chamfer before we reach a full thread is all wrapped up in the tap's name. Here is a straight flute plug tap. This one here is a spiral flute bottoming tap. And just from the name, we know that it's going to pull the chips out of the hole, and it's got about 2 threads worth of chamfer before it reaches that full thread diameter. This guy here is a straight flute bottoming tap with about 2 threads worth of lead-in. And remember, any of these chamfer types, taper, bottoming, plug, can be applied to any of these tap styles. Okay, we know the names and what they mean. Here are some examples of why we might choose one tap over another. Now, this is our classic blind hole. This hole does not go through the part. The engineer has asked for 3/4 of an inch of full thread depth here, but the tap drill is not allowed to break through. With a plug tap, we know that our threads won't be able to reach deep enough with that 5-thread chamfer. So for this particular threaded hole, we'll need to go with a bottoming tap. And because we are tapping so near the bottom of this drilled hole, we don't want to be pushing chips with a spiral point tap. So we're going to go with a spiral flute bottoming chamfer tap. Once again, the only way we're going to be able to tap clean to the bottom of a hole is if there aren't any chips in the way. With this spiral point tap, you're not going to be able to get the tap all the way to the floor of the hole without breaking the tap on those chips. Spiral flute, spiral point. So if this spiral flute bottoming tap works so well, why don't we just use it on all of our holes, even this through hole? Well, these taps are often more expensive, but beyond that, they take the highest cutting force of all the taps on this table. What's happening is we're spreading the load over just the first couple threads, that first 2 threads of chamfer. That means that a bottoming tap is going to always wear out faster than a comparable plug tap. On top of this, a spiral flute tap is typically weaker than a spiral point tap at its core. The flutes on a spiral flute tap need to have enough room for the cut thread wire to escape, as well as for the coolant to find its way in. Because of these needs, the flutes are ground deeper on a spiral flute tap, leaving it with a weaker center core than its spiral point tap cousin. Now, if you broke a tap in the last year, chances are it was one of these spiral flute bottoming taps on tough material. It's a weaker tap. If you're breaking one of these spiral point taps, you're probably going into a blind hole and didn't give those chips anywhere to go. Our spiral point plug tap is usually our first choice whenever possible. Now, it has a thicker core because the flutes don't have to be ground deep enough for chips to escape through them. Now, the plug chamfer on this tap is spreading the load and wear over 4 or 5 threads, requiring lower torque and lasting much longer than a bottoming tap. Now, for these reasons, we're going to use a spiral point plug tap whenever we can, and we're going to save these spiral flute taps for special cases, like reaching the bottom of blind holes. Now, if we do have to hand tap something, it's best to grab a taper tap. The reason for this is that it self-aligns really easily on the hole. It straightens itself out. If you try and hand tap something right off the bat with a bottoming chamfer tap, you're going to have a hard time with alignment. This thing does not want to stay straight. So if hand tapping, grab yourself at least a plug chamfer tap, and best case, taper tap. Now, if you do have to go to the bottom of a blind hole, start off with a plug tap or a taper tap, and you work your way down to the bottoming tap. You can actually follow up the one tap with the other. Now, we've talked about taps and why we choose one over another, but as an NC G-code programmer, I need to know what tap I'm going to use before I write my program. It's important. Now, look at these bolts. These 3 tapped holes all used the exact same G-code program. They were all programmed using a G84 to Z-1 inch deep. But when I go to put the bolts in them, you can tell that some bolts are going in farther than others. So why are the heads of the bolts sticking out at different heights? Well, we use different taps, different chamfers on the taps. So we're not getting the full thread at the same point. This guy was created using a taper chamfer tap. This one was created using a plug tap. And here, this one was made with a bottoming tap. So if you're using a plug tap, you have to account for that extra 5 threads worth of pitch. You've got to program 5 threads deeper if you want to get to that full diameter. Just something you should keep in mind. We talked about cut taps today, and some of you are wondering why we didn't mention form taps. Well, form taps are amazing. They're used on ductile materials that can be crushed or have the threads formed into them. But there's so much that can be said about them that we thought they deserved their own video. But what we do have for you is a few tips that you can use if you're running into problems while tapping. Make sure your coolant concentration isn't low. Taps like higher coolant concentrations. Keeping your P-cool properly set, or even going with a TSC through spindle coolant tap, will extend tool life as well. Check your program. We've made videos on how to calculate those tapping feed rates. And we'll want to make sure that we're running the correct tap drill diameter. Now, you can find this in the machinery's handbook. And remember, there's a range of drill sizes that you can use for any size tap. Use that to your advantage. Sometimes going with a larger diameter drill can make things easier on your tap while still keeping you within our spec. And always check your drill depths, accounting for the angles on those drills and your taps. Some taps are pointier than others, it's just the way they were ground, so you have to think about that before you run them. Now for your drills, a standard 118 degree included angle drill, you can just multiply the diameter times 0.3, and that's going to give you that point length. And finally, talk to your tool reps. These guys know more about tapping than we ever will. One thing I will mention is that if you're tapping on aluminum, you'll probably want to go with a bright finish tap, a nice polished, shiny surface, so the aluminum won't stick to it and gall. And we'll save the black oxide finishes for ferrous materials. The next time you pick up a tap, think snow plow. Just by looking at that cutting tip, you're going to be able to tell if the chips are going to be pushed into the hole or drawn out of it. Now, I want to mention that the names of the taps that we use today are kind of all based in the US, right? Plug tap, bottoming tap, that's universal, taper tap, but they might be called something different where you're working, in the UK or in Germany or Japan. Leave us a comment and tell us what these taps are called where you're at. I'd love to read them. Well, thanks for letting us be a part of your success and for watching this Haas Tip of the Day.